Hey guys, it's me Ty, and we're going to start off with Matthew, who's going to talk about our claim.
For our claim, we think that the effect on gases of pressure and temperature can raise and lower pressure by changing the temperature based on our observations from the crushing can and flask on ice experiments.
Thank you, Matthew. Now let's head over to evidence with Leilani and Vanessa.
One of the experiments we conducted was the flask on ice experiment. First, we heated up a flask in a hot bath and then moved it to an ice bath. While it was in the hot bath, the pressure of the flask was higher than when it was in the ice bath. This is because the molecules in the hot flask were moving much faster than the cold molecules, making the pressure higher.
In the flask on ice activity, we were able to see Guy-Lussac's law at work as well. First, we took the temperature and pressure of the hot bath. Next, we did the same for the ice bath. We noticed that both the temperature and pressure in the hot bath decreased once the equipment was submerged into the ice bath. This relates to Guy-Lussac's law, which states that temperature and pressure are directly proportional. But why does this happen? Well, we know that temperature really is just a measure of the kinetic energy of molecules. So, if the temperature increases, the molecules move much faster than they usually do. When they are in quick motion, they hit the walls of their container more forcefully and frequently, resulting in a higher pressure. This may sound a bit confusing, but all this information can be summed up in the mathematical equation P1 over T1 is equal to P2 over T2.
Thank you, ladies. Now let's head over to Aaron, who has our reasoning.
Our evidence supports our claim because the theoretical relationship in gases between temperature and pressure is Guy-Lussac's law of gas. This makes sense because it tells us the pressure of a gas is proportional to the absolute temperature if the mass and volume are held constant. In the crushing can lab, the soda can was crushed because it was heated and then placed in an ice bath due to the temperature rapidly dropping. Therefore, the pressure decreased. It is even more evident at the flask on ice station where the pressure and temperature are measured directly. The temperature and pressure of the flask on the ice bath was lower than the temperature and pressure of the flask on the hot plate.
Thank you for watching, and we hope you all enjoyed. This right here is our camera setup. So what we got right here is our camera facing downward, taking a picture of our little cartoons, and then we'll take a bunch of little pictures to make a single animation. And so over here we have lots of faces of Leilani. Over here, one's blank right now, and that's the other one. And so we just have to repeat this over and over again. Coffee, very important for staying up late at night. Cheesecake, also very good.